Hello, in this Suncast Bite, we're going to talk about casting, uh, setting decimal places in your output. We're going to talk about the iomanip library, which can help you format your output nicely. And we'll also talk about integer division. So let's look at the program. This program is some of the sample code from our book, Program 217, on page 72. We have the days in the year, which is 365, the number of games played, which is 1,693, and the number of games won, which is 115. We want to calculate a couple of floats, average games per day and the win percent. So in order to do that, average games per day, for instance, we're going to divide games played by days in the year. If we divide two integers, then we are doing something called integer division, and there will be no decimal places. That may not be so important for average games per day, but for win percent it's very important because look, we only won 115 out of 1,693. That's not a lot of games, is it? And the answer to that then would be 0. So what we're going to do is cast one of the variables in the calculation into either a float or double. Well, in this case, a float. And what that does is, since it's in the same expression, in the same calculation with the games played, it will promote games played into a float also. And it will give us a floating point answer. It will even promote this constant 100 because, as you can see, that's an integer too. So in the end, we'll end up with a float, we'll have our decimal place, and we'll have our percentage. So let's see what that looks like. Okay, here it is, 6.79% and 4.64 average games per day. You notice there were two decimal places in the output. We got that using these two lines. Here, we use the fact that cout is an object, and you can see that. See, when you click the dot operator, you get what's called a pick list of all the functions that are available. So for this one, we are using setf, which is set flags. ios fixed means that we're going to use fixed point formatting, and we won't use the exponential formatting. ios show point means that we will show the decimal point. Here, this right here is an example of the iomanip library. Set W is set with. 6 means that it's setting aside 6 spaces into which these variables will be placed, and they will be right justified. And you saw what a nice little table that makes. So that all works pretty well. But suppose we wanted to do something a little bit different. Suppose we wanted to round our percentage to the next highest number. It isn't very high, but it'll sound better if we can round it up a little bit. So let's do this. Float percent is equal to win percent, and I want to go to the next highest percentage. Okay, so that was what was our number? Let's see, I forgot already. Oh yeah, it's mad because I have an incomplete line. Silly me. Let's try it again. Okay, it's 6.79%, and we want it to look like 7%. So float percent, and we're going to use the ceiling function. And ceiling will take it up to the next even float. So it'll take it up to 7.0. So let's add a line. Whoops, too many. Okay, so this is just going to be percent. And this is going to be percent win rate rounded up. Okay, so let's see what that's going to look like. Here we are, 7% win rate rounded up. Well, that worked perfectly, didn't it? Well, suppose I wanted that just to be an integer instead of a float. Well, I can do that, but int percent, if I just, if I just assign percent into an integer, I'm going to have a problem with the compiler. It's not an error, but it will give me a complaint. Let's take a look. I have a warning. Conversion from float to int, possible loss of data. Well, it doesn't realize that I had 0, 0, but it knows that I'm losing my decimal places. So the way to fix that, and we call that compiling clean without warnings, is to cast it into an int. So we're going to use the same type of casting that we did to cast into a float, except this time we're casting into an int. And now the compiler will know that we meant it. We know that we're going to lose those decimal places, and we're fine with it. And so this one is int percent rounded up to int. So let's take a look and see what that does for us. Okay, so we've gone from 6.79 to 7.00 to 7. So we can round all the way up using a ceil. And by the way, there's also a floor function that'll round down to the next even float or double also. And then we can cast it into an integer so that we compile cleanly with no warnings. Okay, that's it for today. See you next time.